In this episode, we are going to be looking at magnetism. Hi boys and girls, at the end of this week's lesson, you will be able to define the terms magnet and magnetism and state at least 4 properties of a magnet, sort materials according to whether or not they are magnets, and state at least 2 ways in which magnets are used, carry out fair tests to investigate magnetism, and complete at least 4 of the 8 activities at the learning centers. There are some objects around us that have a special force that pulls or attracts some objects to them or pushes or repels some objects from them. These objects are made from metal such as cobalt, iron, and nickel. However, magnets do not attract all metals. So a magnet will only attract things that have iron, nickel, and cobalt. So it will not attract anything with aluminium in it. All right. So there are some aluminium windows or louvers. If you were to take a magnet and try to stick it to that, it would fall off. Let's look at some properties now of a magnet. 1. It has a force that pulls or pushes objects without direct contact with them. So it doesn't have to be touching it for it to move. There's a force that it uses to push or to pull an object to itself. Another one, 2. The north pole of one magnet attracts the south pole of another magnet. Unlike poles attract. So positive attracts negative, negative attracts positive. 3. Poles of similar type repel or push away from each other. So like poles repel. 2 positives push away from each other. 2 negatives push away from each other. Last one, number 4. When freely suspended in mid-air, the magnet points in a north-south direction. Part of the Earth's core is always spinning at great speed. This allows it to produce its own magnetic field. Earth has a large magnetic force because it contains iron in its core. This gives the Earth its north pole and south pole, both of which are highly magnetic. Here we have what magnets can look like. Figure 1, this is a horseshoe magnet. And figure 2, we have a bar magnet. So this is just in the form of a bar, and this is in the form of a horseshoe. Now here we have the south pole, and we have the north pole, south pole. And if we were to put these beside each other, north and north, these would repel. North would be attracted to south, south attracted to north. If we put south and south together, they would repel as well. Have you ever seen or used a horseshoe or bar magnet similar to figure 1 and figure 2? Like other materials, a magnet is more than what we see or observe. To observe the properties of a magnet, a fair test must be conducted, as was done when you tested for absorbency and strength of a material. Magnets are used in our daily activities. Example, on the door of a fridge and in speakers. So mom might leave a list of things for you to do before she gets back, and she might put those there. And in speakers, you have magnets. Engage. Get into groups and observe and discuss the outer appearance of a magnet. Explore. Access the internet and download and view videos on magnets and magnetism. Explain. Explain in your own words the definition of magnet and magnetism. Explain to your classmates why some materials are not attracted to magnets. And you need to remember the iron, nickel, and cobalt for this particular explanation here. Next, define the term magnetic field. Extend. Carry out a fair test with the use of 2 magnets and iron filing. Now, iron filings are like those little bits of a knife that when someone is sharpening a knife with a file, you will see those little silver looking things that fall off the knife as it's being sharpened. Those are examples of iron filings. Now look at figure 2. So here we have the iron filings, right? And here we have the magnet. We have the North Pole and the South Pole there. Figure 2 shows the iron filings around the bar magnet. This represents a magnetic field. Now create your own magnetic field. Here's the method. Sprinkle the iron filings on the desk. Then place the bar magnet on the iron filings and observe what happens. If you put the iron filings on the desk, then you're going to see that some of them are going to be attracted to the North Pole, the South Pole. Then we'll have this distribution of the iron filings to show the magnetic field. Question 1. Where do you see the weakest and strongest magnetic field? Now, if we look back at this, we can definitely see that near to the poles we have a lot of iron filings. Somewhere in here, not much there. Not much here. Okay. All right. So that's an observation for you to make. All right. And next question, where do you see a cluster of iron filings? Well, we just checked that one out. Evaluate. Complete at least 4 of the 8 activities at the learning centers. Word link from the Faye Ellington Center. Use resources available to find out 4 ways in which magnets are used. Okay. And let's think about some of these. 1. Magnets are used in buzzers. Magnets are used in security doors. Magnets are used in junkyards. Magnets are used in locks. Okay. They're used in speakers. They're used in microphones as well. Self-link. Dr. Agri Irons Center. Make a journal entry expressing how magnets help you in your daily activities. Music link from the Jimmy Cliff Center. Write song lyrics about magnets and magnetism. Picture link. Edna Manley Center. Draw diagrams of a magnet and the magnetic field. Number link from the Albert Einstein Center. Create a bar graph based on the number of objects in each container. Social link from the Mary C. Cole Center. Send a WhatsApp message with photos of the bar graph and table 1 to your teacher or classmates. The nature link, that's from the Dan McCauley Center. There are some animals that depend on the magnetic field to navigate. For example, birds and whales. Access the internet and find out 3 other animals that use the magnetic field to navigate. Body link from the Rex Nettleford Center. Carry out a fair test. Predicting. Let's go. Complete the prediction by writing one of the words in the brackets on the lines provided. If a magnet comes into contact with all materials, it will repel or attract all or some of them. If a magnet comes into contact with all materials, it will repel or attract all or some of them. Oh, so here is, I see what they're doing. Look at the materials here. Paper clip, it would attract that. Rubber, rubber has no iron, nickel or cobalt in there. Paper, no iron, nickel or cobalt. Copper, would have to test this one. I think it would. Brass, possibly. Sponge, no. Close pegs, or close, well, we say clothespin. The clothespin, if it has a iron, that little spring in the middle that helps the clothespin to remain closed, so it would not attract the wood on the clothespin or clothes peg, but that little iron part there, it might attract that, right? It would attract that. Scissors, yes. Wood, no. Other magnets, depending on the pole, yes. Ruler, depending on the type of ruler. If it's a ruler with steel in there, then yes, because steel has iron in it. A pencil, it could attract the pencil in terms of the part of the pencil at the top where the rubber is. If they use, something with iron to fix the rubber to the rest of the pencil, the wooden part. Nails, yes. Screws, yes. Coins, yes. Keys, yes. And then they want us now to label 3 containers: magnetic, non-magnetic, or both. All right. So if a magnet comes into contact with whichever of these materials, then yes, it will attract some of them, not all of them. Here's a method now. It says step 1, place the objects on the desk. Step 2, observe each object. And then step 3, move a magnet over each object and place it in the labeled container based on the observation. So let's go with our recording. Complete the table based on your observations of the objects placed in the 3 containers. Here we have magnetic, non-magnetic, both. Ha ha ha. So a screw, yes. Wood, no. Close pegs, both. So again, depending on the type of mechanism that is used there. In the middle, if it is made of something with iron, nickel, or cobalt, usually iron here, then it would be attracted to that part, but the wooden part it would not. That's why this one would fall in the category of both. Making inferences. Inferences explain how you arrived at a conclusion. Now, write on each space provided to complete the inference. Some objects are magnetic because they have iron, nickel, and cobalt in them. Some objects are non-magnetic because they do not have iron, nickel, or cobalt in them. For example, something made of pure rubber or plastic or out of pure wood, like a wooden spoon, is not magnetic, right? And an aluminum window, or louver, is not magnetic because it does not have iron, nickel, or cobalt in it. My book, if it's just pure paper and glue, then that will not be magnetic because it does not have iron, nickel, or cobalt in it. Some objects are both magnetic and non-magnetic because they have some amount of iron, nickel, and cobalt along with other non-magnetic material, for example, the clothespin. Drawing conclusions now. Some objects are magnetic and others are non-magnetic, while some are both. So in this episode, we looked at the concept of magnetism and want to pay special attention to this section here that speaks about the properties of magnetism. 1, it has a force that pushes or pulls objects without direct contact. They have a north pole and a south pole, and like poles are going to repel while unlike poles attract, right? And when it is suspended in air, the magnets will always align themselves in a north-south way. So that's important for us to remember, along with the fact that we have magnets in a horseshoe shape, and we can have magnets as a bar magnet. And we also need to remember the importance of the magnetic field. Okay, so go ahead, conduct those fear tests, and you can drop your fear tests in our group folder in the link that will be left below. Take care. See you in our next episode.